Alright, homework help for section 5.4 day 1. Look at 4 different problems today. Going to ask us to use some sum and difference formulas for the most part. And the first one says find the exact value of the sine of 285 degrees by using a sum or difference formula. Another one that we'll take a look at is going to ask us to find the exact value of this expression. Exact value meaning no calculator, of course. Third one, find the exact value of the cotangent of u plus v, so there's a sum or difference formula. Given that the sine of u is equal to 5/13, cosine of v is equal to -3/5, and both of those angles are in the second quadrant, you have a couple problems that are similar to this in the homework. And then the last one's going to ask you to write the cosine of the quantity arc cosine x plus arc sine x as an algebraic expression. And you'll want to pay attention to the work that I do for both of these. They're going to look different because obviously you've got arc cosines and arc sines and you've got actual numbers up here, but the steps that you do for these two problems are virtually exactly the same. So if you can get down the process, it makes it a lot easier if you can see how similar they actually are. Alright, so taking a look at the first one, find the exact value of the sine of 285 degrees. Now they specifically say by using a sum or difference formula. That's something I may not say on a quiz or a test. It's something you'd have to kind of recognize. And I know to do that because I don't know 285. That's not one of the angles that we tend to remember on the unit circle. But I can break that down into two numbers that I do know on the unit circle. So for example, since it's got a 5 in it, I know it's probably a 45 degree angle that I want to use. I can change this into the sine of 240 plus 45. Adding those two together will give me 285, and I do know those two numbers on the unit circle. Need to make sure that you've got numbers on the unit circle you recognize. So if it ends in a 5, that's a clue. 45 is one of the numbers. Alright, now I'm going to expand this out using one of the formulas that I have. So I know the sine of u plus v, if I go and look at my identities, is the sine of the first angle, so it's the sine of 240, times the cosine of the second angle, so times the cosine of 45. Then for that identity, it's plus the cosine of the first angle, so cosine of 240, times the sine of the second angle, so times the sine of 45. So you've got 6 different formulas that you'll have to try to remember, or said eventually when you get to the test you'll have a note card or you'll have a sheet that you can write all these on. Alright, now that I got it expanded out, I just need to simplify each one of these things separately. So be careful when you're doing it. Sine of 240, so think about what quadrant that's in. It's in the third quadrant, so I know the sine is negative. It's a reference angle of 60, so that means the y value must be negative square root of 3 over 2. Alright, times the cosine of 45 degrees, that's in the first quadrant, so it's positive, and both x and y are square root of 2 over 2 for 45, plus cosine of 240, that's again in the third quadrant, so the x value is negative, 60 degree reference angle, that means it's negative 1/2. And then the sine of 45 is square root of 2 over 2, first quadrant, so it's positive square root of 2 over 2. And now I just have to evaluate. Multiplying those two together would give me negative square root of 6 over 4. Multiplying these two together ends up giving me negative square root of 2 over 4. Those are not like terms because the radical number is different. I can't simplify either one of them, so this is actually my final answer, or you most likely will see it probably written like this. So you just have to double check to see if what you have and what they have is the same thing. Both of these count if you combine them together and say it's over 4 and keep them both negative. That counts. It's fine. It just depends on how they write it. Either one of those would be fine. Alright, number 2 is asking us to find the exact value. And when I look at that, that is one of the sum or difference formulas for tangent. So it's more I just have to recognize that it is. Because like I said, when it comes time to the test, you're going to have a lot of different formulas. You just need to identify somewhat quickly which formula you're dealing with. So I recognize that this is a difference formula for the tangent. So this, if I changed it into the identity, would be tangent of 5 pi over 4 minus pi over 12. If I looked up the identity and I expanded it out, it would give me that. So now I've switched it to this. I can go ahead and add or subtract those two together by getting myself a common denominator. So multiply by 3 over 3 gives me 15 pi over 12 minus pi over 12. And as I continue to simplify, that is eventually going to give me the tangent of 14 pi over 12. Which, if I had to do without a calculator, would make me nervous seeing that 12, but of course it simplifies. So that's going to give me 7 pi over 6, and now that's a denominator I'm more familiar with. It's a reference angle of 30. 7 pi over 6, it's in the third quadrant. And since it's a reference angle of 30, I know it's square root of 3 over 2, 1/2. And of course they're both negative because of the quadrant I'm in. Alright, it's asking me for the tangent, so I know I'm going to divide them. The fact that they're both negative means I can basically ignore that. They're going to cancel each other out. I know the 2's when I multiply by the reciprocal eventually cancel. It's really going to give me 1 over the square root of 3, or I'll rationalize that to square root of 3 over 3. So there's my exact value for that expression. Alright, the last two I have to be careful. What everyone wants to do is use these specific numbers, and I'm going to use them somewhat, but I'm not going to use it right away. When I look at this is what I need to focus on. They're asking me to find the exact value of this. Well, that means I need to go back and look at one of my identities. Now, we don't have an identity for cotangent, but I know that cotangent is the reciprocal of tangent, so I'm going to basically just change this into tangent. I'm going to pretend that this is the tangent of u plus v. And so now I'm going to expand this out, and according to the identity that we have, this would be the tangent of u plus the tangent of v divided by 1 minus the tangent of u times the tangent of v. Now realistically I'm finding the cotangent, so if you wanted to flip it over right now, you could. I usually do that at the very end. It's up to you. Probably it'd actually be a good idea to do it right away so you don't forget, but I always do it at the end. Alright, so now I've got this. Now I need to figure out what's the tangent of u. Well, I don't know what the tangent is. I know what the sine is. So now I'm going to take this information and I'm going to draw a right triangle. Now they told us that they were both in the second quadrant, so when I draw this picture, make sure that you pay attention to that. There's angle u, this sine, so opposite over hypotenuse is 5 over 13. I can quickly do the Pythagorean theorem and find out that this is 12. Why is it important that it's in the second quadrant? Because that's a negative 12. Alright, well now I'll do the same thing with v. Angle v is also in the second quadrant. It tells you the cosine is negative 3 over 5. Pythagorean theorem will tell me that this is 4. And now that I've got the triangles filled out, now I can figure this out. What's the tangent of u? Well, here's angle u. Tangent is opposite over adjacent. This whole term will become negative 5/12. Plus the tangent of v is negative 4/3. Divided by 1 minus tangent of u, tangent of v, it's just those two numbers again. So it's negative 5/12 times negative 4/3. And now it's just simplifying this. So, getting a common denominator here, I know that I'm going to have to multiply by 4 over 4. That's going to give me negative 16, negative 5, so negative 21 over 12. Divided by, don't need to get a common denominator here because I'm multiplying. Double negative, these are going to cancel, it's still a minus sign. I can see that the 4 would reduce with this 12 to make it a 3. So the second number here is 5 over 9. Now I waited for the 1 because I wanted to see what this denominator was. I would change this to 9 over 9. So I am looking at negative 21/12. Now you may or may not see that they have 3 in common. If you do, go ahead and factor the 3 out. That's going to give me negative 7/4 divided by, that's going to eventually give me 4/9. And so now I can multiply by the reciprocal. So it's going to become 9 over 4, and that's going to give me negative 63 over 16. Now remember, this is what the tangent of u plus v is. I want to know what the cotangent is. So now I just need to take the reciprocal. And I can say the cotangent of u plus v is equal to negative 16 over 63. And there would be my answer. Like I said, if you feel like you're going to forget to flip that over because after doing all that work it would be easy to forget, maybe flip this right away, take the reciprocal, and then you won't have to worry about it. Said I just don't normally do it that way, so, but it really doesn't matter which way you do it. All right, so now, again, notice what I did up here. I'm going to do the same thing here. It's asking me for the cotangent of u plus v. This one's asking for the cosine of u plus v. These, because it's arc, these stand for angles. So the first thing I'm going to do, not that I have to do this first, but the first thing I'm going to do is I'm going to expand this. So if you go back and you look up your identity, if you don't remember it, if you're looking at the cosine of u plus v, that identity is cosine of u, so cosine of arc cosine x. This is my u and this is my v. So it's cosine of u times cosine of v. And again, our angle v is arc sine x. So there's the first part of it. And then because this is plus, the identity says that you use minus sine of u times sine of v. And u is arc cosine x times sine of v, which is arc sine x. So again, you have to kind of see this as u and v and then expand it out. This is really just saying cosine u, cosine v, minus sine u, sine v. Alright, so that's kind of what I did here, expanding it. Well, what else did I do? I took these two pieces of information and I made right triangles. This is the same thing. Remember, this is kind of in a roundabout way helping me figure out what the angle is. Well, that's what this is doing. I can actually draw a right triangle for this. So I'm going to do that over here. I'm going to say this is my arc cosine x triangle, just like I would have drawn a triangle for this. And if I draw my right triangle, since it's a variable, I'll just assume it's in the first quadrant. Its cosine is x, or x over 1. That means that cosine is x adjacent, hypotenuse is 1, and if I do the Pythagorean theorem, it's 1 squared minus x squared, the square root of that, without actually showing it out. So there's that triangle, just like I did up here. Why did I draw that triangle? Because it helped me figure out what the tangent of that triangle was. Which, if you look up here when it says find the cosine of that triangle, this is telling me to look at that particular triangle. I also need to draw a triangle for arc sine, so I'll do that right below it. And again, since it's a variable, assume it's in the first quadrant. And then because it's sine, that means it's opposite over hypotenuse. Basically same information, you're still going to get 1 minus x squared, it's just in a different spot is all. And so now I'm going to use this just like I used these two triangles up here to fill in this information. Alright, so now it wants me to find the cosine of that triangle, that one. So the cosine of this triangle is x over 1, it's just x. Times cosine of arc sine. There's the arc sine triangle. The cosine of it is that radical over 1. So square root of 1 minus x squared over 1. Minus, now I want to know what is the sine of the arc cosine triangle. There's the arc cosine triangle. The sine is that radical over 1. So square root of 1 minus x squared over 1. Times the sine of the arc sine triangle. The sine of this triangle is x over 1. So now I've got it completely expanded out, and now all I have to do is go ahead and finish off my calculations. So let's go ahead and do that. And it looks like if I multiply, I'm going to get x square roots of 1 minus x squared minus, multiply, it's x square roots of 1 minus x squared. And what that look like it's going to happen? Yeah, you're going to add those together, you're going to get 0. And so your answer for this particular one is just 0. Probably not going to happen all the time that you end up with 0. You probably get some sort of function, but for this one it ended up being 0. Hopefully you are able to identify how similar these two are. And make sure that when you get into problems, I think it's in the 30s and 40s when you're doing something like this, that you're careful with this. This is a problem that gives a lot of people mistakes, so just make sure that you're double checking your answers. Alright, that's the homework help for the first half of 5.4. Let me know if you need any extra help.